A social gaming application supports the transfer of gift vouchers between users. When a user hits a certain milestone on the leaderboard, they earn a gift voucher that can be redeemed or transferred to another user. The development team wants to ensure that this transfer is captured in the database such that the records for both users are either written successfully with the new gift vouchers or the status quo is maintained. Which of the following solutions represent the best fit options to meet the requirements for the given use case? Select two. A, perform DynamoDB read and write operations with consistent read parameter set to true. B, use the Dynamo transactional read and write APIs on the table items as a single all or nothing operation. C, complete both operations on Amazon Redshift in a single transactional block. D, complete both operations on RDS MySQL in a single transaction block. Okay, so the answer is B and D. You can use the DynamoDB transactional read and write APIs on the table items as a single all or nothing operation. Or D, complete both operations on RDS MySQL in a single transaction block. Next question. A startup has been experimenting with DynamoDB in its new test environment. The development team has discovered that some of the write operations have been overwriting existing items that have the specified primary key. This has messed up their data, leading to data discrepancies. Which DynamoDB write option should be selected to prevent this kind of overwriting? A, use scan operation. B, batch writes. C, conditional writes. D, atomic counters. The answer is C, conditional writes. DynamoDB optionally supports conditional writes for write operations. And the main thing is a conditional write succeeds only if the item attributes meets one or more expected conditions. So you could prevent an update item operation from modifying an item if its attribute, if one of its attributes has a certain value. Okay. A company runs its flagship application on a fleet of Amazon EC2 instances. After misplacing a couple of private keys from the SSH key pairs, they have decided to reuse their SSH key pairs for the different instances across AWS regions. As a developer associate, which of the following would you recommend to address this use case? A, generate a public SSH key from a private SSH key, then import the key into each one of your AWS regions. B, if it isn't possible to reuse it isn't possible to reuse SSH key pairs across AWS regions. C, encrypt the data, encrypt the private SSH key, and store it in the S3 bucket to be accessed from any AWS region. D, store the public and private SSH key pair in AWS Trusted Advisor and access it across AWS regions. Okay, so they're misplacing a couple of private keys. Okay. All right, A, generate a public SSH key from a private SSH key, then import the key into each. Okay, so this allows you to generate a public key from the existing private key, and then you can import it to the different AWS regions. Okay. A development team is working on an AWS Lambda function that accesses DynamoDB. The Lambda function must do an upsert. That is, it must retrieve an item and update some of its attributes or create the item if it does not exist. Which of the following represents the solution with minimum IAM permissions that can be used for the Lambda function to achieve this functionality? A, DynamoDB. Well, they all say it. Okay, update item, get item, put item. B, update item, get item. C, get records, put item, update table. D, add item, get item. Okay, B, get update item and get item. The update. Okay, just the key part is update item will edit an existing item's attributes or add a new item to the table if it doesn't already exist. That's the key point there. Okay, an auto-scaling group has a maximum capacity of 3, a current capacity of 2, and a scaling policy that adds 3 instances. When executing the scaling policy, what is the expected outcome? A, Amazon EC2 auto-scaling adds only 1 instance to the group. B, Amazon EC2 auto-scaling adds 3 instances to the group. C, Amazon EC2 auto-scaling doesn't add any instances to the group, but suggests changing the scaling policy to add 1 instance. D, Amazon EC2 auto-scaling adds 3 instances to the group and scales down 2 of those instances eventually. The answer is Amazon EC2 adds only 1 instance to the group.